Hi, welcome to Lesson 24D, Quantiles or K-Values. The goal of today's lesson is to learn about the pure majesty that are quantiles. So, we've been looking at, we've been given certain x values that are somewhere along the curve. Here's the normal distribution curve, and suppose we've been given like an x value. And what we need to do is then find the area under the curve to determine what that probability is. Remember that the area under the curve is equal to 1, and any sort of area under the curve, for example, perhaps this area is, let's say 0.3 for example, that area is the probability that whatever we're looking for is less than this value. So if we're saying what's the probability that x is less than this, we say okay, well, we figure that out and we figure that it's 0.3 or 30% probability. Okay, so we've been doing that a fair amount, and in lesson 24C what we looked at is we were looking at when we need to standardize things. We have to take this formula where we take our value x and we subtract the mean and we divide by the standard deviation, and that standardizes the value of x so that we can compare it with different things. We could compare, as I mentioned in the last lesson, apples and oranges. Then we could compare somebody's mark in, say, physics class, where the physics class has an average mu and a standard deviation sigma, and compare that to, say, a math class where there's a different mean and a different standard deviation, and we could see how the student compares in both classes given that all these values are different. Okay, so that's what we were looking at in 24C. Now, in this lesson, and we'll deal with it mainly more in examples in class, but we're going to take a look at if one of these values, the mean or the standard deviation, are not known, but we know the z-score and we know the value we're thinking of, and then one of these two values we can then find the other value. In more complicated situations, we may not know either the mean or the sigma, the standard deviation, but then we could use this equation in two different circumstances and then be able to simplify and work out what the final mean and standard deviation are. Okay, so we're going to deal with that in examples in class tomorrow. What we will look at right now is we'll look at how we would be able to go about, suppose we were given a certain area, a certain probability. Suppose we're given there's a probability of, I don't know what that might be. Let's say the probability would be for all of this area, all here to the left of this. Suppose we're looking at a probability of 0.55, for example. Probably a little bit more, let's say 0.65, just to be a little bit more realistic. And then we have to say, okay, well, what value here will give us this area under the curve, or this probability of 0.65? And when it's given in that circumstances, or those conditions where we have to find this value, that's the quantile or the k value that we have to find now. So given the area, or given the probability, what's that k value that will then produce that probability? Okay, so that's what we're going to find now in certain examples. So I'll go through an example now with you. Now, as things were explained in 24B, not in the video but in class, we were looking at the idea that these standard normal distribution curves, these normal distribution curves are filled in from the left. So we fill them in from the left side all the way over to the right side, So when we're looking for something that is less than a certain value, that's no problem. We can just do, okay, well, what's to the left or less than this value? We can work that out no problem on the calculator or using other algebraic means. When we're dealing with things to the right of that value, that's where we have to use the fact that the whole area under the curve is 1, and because it fills in from the left, okay, so we're filling in from the left, and we need to know this area, what we need to do then is we have to subtract 1 minus this to then leave us with this part here. So instead of saying what's greater than, say that's what's greater than 0.35, what we need to do is we have to turn that around and say, okay, well, what's less than 1 minus 0.35, or what's less than 0.65, and then once we get that value, that will give us the value that's here. Okay, so we would be subtracting 1 minus the probability of 0.35 to give us this probability up here. Sorry, no, not 0.3. We would be subtracting 1 minus 0.65, and that would give us what's greater than this k value, giving us the 0.35. Okay, so we have to take what we know to the left of this value, subtract that area from 1, and that will give us this area or this probability that's to the right of this value that we're looking for. Okay, so we're going to take a little look at a quick example, and we'll see how all this works. Okay, so let's move along here. I'll move some of this stuff out of the way and move this up here. So here's another curve here that we can use. So let's say we've got some machine that's producing screws, and the screw that's produced by a machine is normally distributed with a mean of 75 millimeters. So you've got a mean of 75 millimeters. And we've got a standard deviation of 0.1 millimeters. If a screw is too long, it is automatically rejected. So if 1% of the screws were rejected, what is the length of the smallest screw rejected? Okay, so if it's too long, so the higher up along this curve we go, the longer the screws are, and we're saying if 1% of the screws are rejected, so right up here, and this isn't even the best estimate of 1% of this area under the curve, but we'll just say that's 0.1 right there, 0.01. If 0.01 or 1% of the screws are rejected, what's the length of the smallest screw? So as we move further along to the right here, the screws are getting longer and longer. So what's the smallest screw length? Well, that's right here, and that's the K value we're looking for. Now, as I just described or explained before, the area is filled in from the left. So the only thing we can do when we're doing this calculation, we can only find the area or the probability to the left of K. So what we need to do is we need to get that value, and then once we get this value, we can subtract that from 1 to give us what's on this side. Okay, so the value that we're going to calculate will be the area all under here. Okay, so x is normally distributed. X is normally distributed with a mean of 75 and a standard deviation. Well, this is variance with a standard deviation of 0.1. Okay, so what we need to do is we need to find the probability that x is greater than or equal to k. So this k value that we're looking for, we need to know. And that has to equal 0.01. This is the area we're looking for, the probability we're looking for. But because we can't find to the right of this k value, we have to find what's to the left of it. We need to find then x that is less than or equal to k. And then by subtracting, we do 1 minus 0.01, of course. And that's going to give us 0.99. So we're doing less than k, which is 0.99. And because we're finding the k value that corresponds to the boundary that produces the 0.99, the area under here, we're finding all this area, even though we're talking about less than k, all that's less than k, which is 0.99, we're still going to find this k value. Okay, so what we're going to do is we're going to take our calculator, and this is the TI-84. We're going to turn this bad boy on. And so what we're going to do is we're going to find the inverse norm. The inverse is what the function is going to be, because we now know the area, which is 0.99. We need to find the k value that corresponds with that boundary. So we're going to do second, and then this vars, second variables, which is actually the distribution. And we get that menu here. So we're going to go down to 3. So inverse norm is 3. So norm is the normal distribution, and inverse will be giving us this k value, the quantile that we're looking for. And the area that we're looking for is 0.99. And the mean that we found, sorry, as I'm looking at my notes, is 75, and the standard deviation is 0.1. So that's the area, that's the mean, that's the standard deviation. We paste that into our inverse norm, and this is going to give us this is going to give us the boundary k that separates the 99% to the left of k and the 1% to the right of k. And we see that that's 75.2326. So that means that k is approximately equal to 75.2 millimeters. So that means that there are screws that are longer than 75.2 millimeters. All of those are going to be rejected, but the shortest of all the longest screws in that 1%, the shortest of those longest screws is right at 75.2 millimeters. So that's the shortest of the screws that are rejected in this example. Okay, so all of those, the 1% above that, will all be rejected. Okay, so there are going to be other examples that we'll look at tomorrow in class, but the k value is just the boundary that we're looking for, as opposed to being given the boundary and finding the area. Now we're given the area and finding the boundary. Okay, so what I'd like you to do now is I'd like you to look at example 7 and 8 on page 644. Allow the self-tutor to explain things to you. Then take a quick glance at exercises 1 through 4 on page 644 to 645. Then follow behind by doing example 9 on page 645. And then taking a quick look at exercises 5 and 6 on page 645. And 9 on 646. Then we look at example 10 on page 646, followed by exercises 1 through 4 on page 646, and then once again followed by example 11 on page 647, followed by taking a look at exercises 5 through 7 on page 647. So if you look at all those examples and take a quick look at those exercises, you'll you'll see what you've got in store for you for tomorrow in class, and the self-tutor will be able to provide some of the information for you that you may need to know in solving some of these problems. And in class tomorrow, we'll take a look at a few examples just to kind of round out and complement the learning of this lesson. So, thanks for watching, and we'll see you in class.